In this section, we're going to be talking about relations. Now, what is a relation? Basically, it's any relationship between x and y. Any expression that you might have with x and y in it will represent a relation. Now, the domain of an expression is the set of x values which can be substituted into the expression, and the range is the set of values which can result from the expression. Now, what I'd like to do is go back to some familiar notation for you. You are used to the old XY chart when it comes to plotting points on an XY axis. And you might have thought of these as input and output values instead. Well, now basically the domain is your x values, which are the numbers that can be substituted in, and the range are these y values that come out. So it's a familiar concept. We're just going to be dealing with it in a slightly different way. Now let's look at y equals x squared. What is its domain? Is there any value that cannot be squared? The answer is no. So basically our domain is going to be all real numbers. Now, when you square a number, can any number be the result? Well, no, only positive numbers and 0 can come out, so our range would be 0 to infinity. Now you have to know something about the equation y equals x squared to be able to answer this question. And we're going to learn how to do this both from a graph, and there will be certain equations that you will be responsible for. Now, in general, when you are finding the domain of a function, the default answer is going to be all real numbers. If you are in doubt, right off the bat, you just say all real numbers, that's my answer, and go from there. However, there's certain things that you want to take into consideration. You want to take away x values which create zeros in the denominator, because you know that whenever you divide by 0, an expression is undefined. You also want to take away x values which create negatives inside square roots, because you cannot have the square root of a negative number. And I'm going to put a third restriction on here, which won't become an issue until later in this class, but we will also take away x values which create zeros or negatives inside logarithms. So let's look at a few examples. Right here in this first problem, we see that there is a denominator. We know that x minus 3 cannot equal 0, and therefore x cannot equal 3. Now let's get a little bit technical here. The domain is the set of values which can be substituted in. I don't say that the domain is x not equal to 3, because that's not stating what the domain is, it's stating what the domain isn't. So instead we want to write this as negative infinity up to 3 joined with the next set from 3 to infinity. And this will be all values except 3, which state what values can be substituted into this expression. In this second problem, we see a square root, and we know that x minus 3 must be greater than or equal to 0, and adding 3 to both sides, we know that x must be greater than or equal to 3. So the domain in this second part here is going to be from 3, which we include, up to infinity. In this third case, we can see that this denominator is going to factor into x minus 3 times x plus 2, and we need to make sure that those are not equal to 0. So x cannot equal 3 or negative 2, both of which are bad values. So our domain will be all values except those. In other words, from negative infinity up to negative 2, which we don't include, united with the set between the numbers, and then united with the set or interval to the right of those numbers. So in general, when you have an expression you're trying to find the domain of, start with all real numbers and watch for two things right now. Watch out for denominators and watch out for square roots. If there's a denominator, make sure that you make those values that create a 0 in the denominator are not included in the domain, and use a greater than or equal to restrict it to only positive or 0 values in a square root. Later on, we will add in the restrictions dealing with logarithms, but that'll be towards the end of this course.